Customers arrive to a single server system in groups of 1, 2, 3, and 4 customers. The number of customers per group is independent and identically distributed. There are in total 16 places in the system. In this tutorial, I am going to write down the given system using Kendall's notation. So given that information, I'll start by looking at what Kendall's notation says. We can denote a queuing system by the letters A, B, C, D, where the A is the distribution function of the inter-arrival times. In this case, the distribution function of the inter-arrival times is not specified. And when it is not specified, then we just assume that it is a general distribution. And for a general distribution, we will denote it by a G. So where we have the A there, we'll put a G to denote that we have a general distribution for the inter-arrival times. The second letter, the B, is the distribution function of the service times. In this case, that distribution function is not given again. So we just assume that it's a general distribution and we will denote it by a G. Where we have the B there, we'll put a G. And then the C there is the number of servers in the system. In this case, we are given that there is one server because it's saying a single server system. So for the C there, it will be a 1. Then lastly, the D. The D is the holding capacity of the system. In this case, we are given that there are in total 16 places in the system. So the holding capacity there is 16. So where we have the D there, we'll put a 16. So in terms of Kendall's notation, the queuing system, we can denote it by G116.